Okay, so we are continuing into our exponential unit, and we have learned how to solve exponential equations. We've learned how to simplify them. So now we are going to talk about some specific ones that are used in the real world, and that is exponential growth and decay. Okay, so growth means you're getting bigger, right? So the base value, like base to our exponent, has to be bigger than 1. And decay means that you're getting smaller, so your base has to be between 0 and 1. Okay, no negative bases in this case, right? We don't have negative bases. We have negative exponents, which are possible, but you do not have negative bases. So somewhere between 0 and 1, which basically either means a decimal or a fraction, right? So note to self. So a decimal or a fraction, and it cannot be an improper fraction, right? So, because if it's an improper fraction, then it's bigger than 1. So a decimal or a fraction between 0 and 1 for decay. Okay, both of these, the exponential growth and decay, have the same variables, right? And there's some specific variables that we're going to talk about. We have this little a, which is our initial or starting amount. Okay, we have our r, which is our rate. Right? And when you're talking about growth, it's how much are you gaining? And when you're talking about decay, it's how much are you losing? Okay. And then we have time. So your time could be pretty much anything. Could be seconds, it could be years. You may have heard this in your physical science classes where they were talking about maybe carbon dating or things like that is used as an exponential decay because carbon decays at a very specific rate, and you can actually tell how old something is based on how much is left. Okay, how much carbon is left in it. But it could be anything. It could be seconds, years, weeks, months, whatever. Okay, some very specific times and some very specific rates that we need to talk about. Okay, if you are doubling something, okay, then your rate is 100%. There's a reason for this, so just write this down and keep it in mind because I'm going to show you what the equations look like. Okay, and the reason that is 100% is that whatever you put in, you're getting 100% back, which means you're getting your original plus 100% more. Okay, half is 50% or 0.5, or you'll even see it as a base of 1/2. Okay, and then tripling is your R value is 2, and it basically means 200%, right? Because if you think about 100% or 200% as a decimal, right, converting between decimals and percents, 100% would be 1, 200% would be 2, and 50% would be 0.5 because you do move the decimal over 2 places to the left. Okay, so what the actual equations look like. So this make a little bit more sense on why R is the way it is. Okay, so exponential growth right here. And take a look. This is my base, and my base has to be bigger than 1 because I've got 1 plus whatever my rate is added to it, right? So the base has to be bigger than 1. Again, same here. This has to be decay because I'm taking 1 and I'm subtracting whatever my decay rate is. So my base has got to be less than 1, right? Somewhere between 0 and 1. All right, so let's take a look at a couple of examples so that you can see whether it's growth or whether it's decay and how you can tell. Okay, so we have y equals 500 times, because that is a parentheses, times 1.60 raised to the 5th power. Okay, so I didn't include it on here, but I am going to ask the initial amount is 500. We don't know what that is in this case because there's no context behind it, but our initial amount is 500. Could be $500, could be 500 grams of carbon in something that you are trying to figure out. It could be anything. So initial amount, 500. Okay, is it growth or decay? So take a look at your parentheses, look at your base. Is your base greater than or less than 1? It's greater than, which means this is growth. Okay, now this is where it gets a little bit interesting. Notice that 1 is part of both of these formulas, right? So your growth rate is whatever you added to the 1. Your decay rate is whatever you subtracted from 1. So my rate is not 160%. My rate is the part that is greater than 1. So my rate is 60%. So that's how fast it's growing. Okay. If you know its growth and you know that the growth setup is 1 plus r, you can actually solve the equation. 1 plus r equals 1.60. And you can find out that your rate is 0.60, which is 60% as a percentage statement. You do the same thing when you know it's decay. You can make an equation, 1 minus r equals, and it'll be whatever's in the parentheses, and you can solve it that way as well. So if you're not sure. Okay, so now we have y equals 200 times, parentheses, 0.75 raised to the 6th power. And again, I didn't write it down, but let's go ahead and put it in there. The initial amount is 200. Okay. Is it growth or decay? Again, look at the base. Is it greater than 1 or is it between 0 and 1? It's between 0 and 1, so it is decay. If you're trying to figure out how much decay, the decay rate is not 75%. Right? Remember, if this is decay, then it's 1 minus r equals 0.75. Okay, so how would you solve this equation? Well, same way, you would subtract 1 from both sides, and then you're going to have to divide by -1 to get rid of that negative. So my rate is actually 0.25 or 25%. Okay, how much less than 1 is this? How much did you take away from the one that's always supposed to be there in the original problem to get to 75%? Well, you took away 25%. Okay, so very, very basic. You can actually find out, like if you were to give this problem context, you started off with $200 as far as what your phone was worth, and it's losing 25% a year for 6 years, and you could find out what your phone is actually worth by just putting this in your calculator. So very, very basic as far as being able to pick things out. So let's move it up a step. So we can actually solve for the y, which we call basically our outcome. We can solve for a, which is our initial amount, right? Or we can solve for t, which is our time. Okay, so we can actually solve for 3 out of those variables. We can't solve for rate. You'll do that when you get into algebra 2. Okay, so we basically substitute in everything that we have to solve for whatever is left over that we want. Okay, so let's go with the first one. How much money will you have? Okay, well, that's an outcome problem. I want to know what my outcome is going to be in 25 years. That's my time. If I started with 2,000, there's my initial amount at an interest rate of 5%. There's my rate. Okay, so I have everything else. I'm just going to substitute it in. All right, so y equals 2,000 parentheses. Now, this is a growth rate, right? This is not a decay rate. We can tell that just because there are key words that we'll see when you're talking about a decay, things like depreciation, losing money, things like that. So this is going to be 1 plus, have to put this in as a decimal, 0.05 raised to the 25th power. Okay, sorry about that. Had to get my calculator. So you're going to put this in exactly the way you see it in one shot. Make sure you're putting 1 plus 0.05, right? And make sure you're using the little up caret button on your calculator to get to those higher exponents. And then you're going to put in 2,000 parentheses, 1 plus 0.05 raised to the 25th power. Okay, and I don't know if this is right. I'm going to try it one more time just to be sure. And I'm getting $6,772 since this is money, and 71 cents rounded to the nearest penny. So hopefully that's right. I'll have to check with my other calculator because right now I'm using kind of a basic one. Okay, So, but it's very, very straightforward. Again, you are literally just putting in everything you've got. Those are really, really easy problems when you're solving for your outcome. The harder ones are coming up. So 1.05, let's just make sure. Yep, okay. So let's try a slightly harder one. Okay. Okay, so what would your phone be worth? So again, this is an outcome problem, right? In 3 years, there's my time. If you paid $800 for it, there's my initial amount, and it loses. Okay, so there is our cue that this is going to be a decay problem, and that is my rate. Okay, so the setup. So y equals initial amount 1 minus 0.70 as 70, right? Raised to the third power since it's 3 years. And again, you're going to put this in very specifically, just like you write it. And we're going to find out what your phone is worth after 3 years. Okay. All right, and I am getting $21.60. Yep. Okay. So again, very straightforward. Everything else goes in. It's just catching those keywords as far as loses. And again, like I said, if you want to write this down, you have depreciation or depreciates, which also means that you are losing value. Okay. So you'll hear people say about how your car depreciates, or your phone or your computer, things like that, all lose value every year. It's just the way it works. All right, so let's try a harder one where you're actually going to solve for either time or you're going to solve for the initial amount. And again, these are pretty much going in the calculator. Okay, so how many years will it take to have $364,500? That's supposed to be an if you started with $500 and you are tripling your money every year. Ooh, okay, so how many years is what I'm being asked for? So I am solving for time. Okay, so let's see. I want to have $364,500. That is actually my outcome. That's what I want to end up with. So that means this is my initial value. And tripling, remember that specific value of R, when you're tripling, R equals 2. Okay, so you'll see why when we substitute this in. So we're trying to find how long. Okay, so the setup in this case, because the Y is the outcome, let's see, initial value of 500. See, this is the reason why the R is 2. 1 plus 2 is 3. You're basically repeatedly multiplying because you get your original amount back plus 200% more. You're multiplying your amount by 3 every single time. And we are solving for the year. Okay, so this is very interesting as far as working backwards to solve for an exponent. This is something totally new. All right, so stay with me because you're going to solve this like you solved your exponential equations. So let's simplify this just a little bit. Okay, so now I can see that my base is 3. Right? And remember your PEMDAS, you're not going to multiply 500 times 3. That's not in the correct order. That's 500 times 3 to some power. And our goal is to figure out what the power is. So we're going to work backwards. We are going to divide both sides by 500. Okay, so both sides divided by 500. Nope, not that. Divided by 500. Okay, so I'm getting 729. So 729 equals 3 to some power. And we're going to treat this just like our exponential equations. What you're trying to do is rewrite 729 so it has a base of 3. So your goal is to figure out 3 to what power is going to give you 729. Okay, and I'm sure you're probably trying it in your calculators now, and that's exactly what you're going to do for problems like this. This is actually 3 to the 6th power. So that means it's going to take 6 years, right? If your money is tripling every year, it's going to take 6 years to get to $364,500. Okay. So again, this is a lot like the exponential equations we've already done. And yes, you're definitely going to use your calculator to get this. All right, last one. We've solved for everything but the initial amount. So we know that just from looking at the question. I am solving for my initial amount. Okay, I want to have 5,000. So that is my outcome. Okay, and my time and my rate. So I have everything else but my initial amount. So again, that's the only part that you're going to leave blank. And this is not a decay rate. So you can actually tell there's no decay word or depreciation. So it needs to look like this. And you literally have everything except for A. All right, so let's check it out. I want to have $5,000. I don't know what I have to put in the account, but I know I'm going to get 10% interest, and it's going to be for 12 years. This is actually very easy to solve simply because this A is being multiplied by this entire expression right here, this parentheses raised to the 12th power. Okay, let's go ahead and simplify that just a little bit. 1 plus 0.10, just so you can see the base, raised to the 12th power. A is being multiplied by this whole thing. Okay, and if A is being multiplied by that, in order to get A by itself, we have to divide by that. So in your calculator, using your fraction button, you're going to have 5,000 divided by 1.10 raised to the 12th power. Okay, and what I'm getting is $1,593.15. Yep, $1,593.15. Again, one of the very easy ones because all you have to do is divide. I know the time ones take a little bit more work, but again, this is really just another type of equation that you're going to have to work with. Okay, so let's see. One more and then we'll be good to go. Okay, so I am solving for time. That means I'm going to need to get those common bases just like I did last time. Okay, so this is my outcome. And the reason I know it's my outcome, I'm going to have. That means it's a future, right? That's a future amount. So that has to be your outcome. And here it says that you started with this. So this is your initial value. Okay. And you're losing half per year. So that means my rate is 0.5. Half is 0.5. All right. So again, we're going to substitute it all in. 6,250,000. 1 minus, because I'm losing half, 0.5 raised to the t. Okay, let's simplify that. 625,000, and that's going to be 0.5 to the t. So I know my base is 0.5, and I know when I simplify the rest of this, I need to get it to that same base. Okay, so 3125 divided by, so 3,125 divided by the 6 million, because I got to divide by that on both sides, right? I'm still trying to work backwards to get my stuff by itself. And remember that if you end up with a decimal, you can hit that little double arrow button on the bottom right, and it will give you the fractional equivalent. Okay, so I got 0.0005, which is the same as 1 over 2,000. Let's make sure. I think that's 1 over 2,000. Yep, 1 over 2,000. Or basically 5 over tens, hundreds, thousands, 5 over 10,000, basically. You could also think about this as a base of 5, right? You can make both of these a base of 5. If you remember your scientific notation, what would I have to multiply this by to get it to equal a whole number 5? Well, 1, 2, 3, 4 places to the negative. Right? That is 5 times 10 to the negative 4th. And this would be 5 times 10 to the negative 1, right? To make 0.5. Okay, bases match. Bases are both 5. The 10s match, so that's there. So basically what you have is that negative 4 equals negative 1t, since both my bases match. And if I divide by negative 1 on both sides, I get t equals 4. Okay, if you're having a hard time with that one, I get it. The decay ones are kind of weird. Again, this is 1 over 2,000 equals 0.5 to the t. You can also, in your calculator, just keep putting 0.5 to some power, right? Until you get 0.0005 or 1 over 2,000. Because the ones that you're going to be solving are not going to be really decimal answers on this. Okay, so that's it. We're just going to be working on exponential growth and decay. See you next time.